Alrighty guys, so as I promised before we went on break, and by the way I hope you all had a really nice restful break, I promised that when we came back, because we just learned the trig right before you left, that I would review it again. So we're going to review it and you're going to do some more practice, and then the next video for next class we're going to move on. Okay, there's just a little bit more trig left after this, but I don't want to overwhelm you with a big formula today. Okay, so we'll do that next time. Anyway, this is section 8.4 from your book, and remember we're only working with right triangles. And just Ella down, sorry, remember that we're working with right triangles only, and that the vertices, right, the points on the triangle, the vertices, are labeled with capital letters, and the sides opposite those angles, so this is angle A and angle B and angle C. We know that angle C is 90 degrees, right? But the sides opposite those angles are labeled with the little corresponding letter. So side opposite angle A is little a, side opposite angle B is little b, okay? And when we don't know what the angle measure is, that's okay, because oftentimes they just want you to find the ratios of the sides, right? And so the rule goes like this: SOHCAHTOA, right? Means the sine is the side opposite over the hypotenuse, the cosine is the side adjacent over the hypotenuse, and the tangent of an angle is the side opposite over the adjacent. So I did that. I broke it down for the SOHCAHTOA, so sine, cosine, tangent, and these two letters here, if you remember, give you opposite over adjacent or opposite over hypotenuse, depending on if it's the sine, the cosine, or the tangent. So we did this in class, but if we wanted to write the ratios of the sides of this triangle, for example, the sine of A, which I did in purple, that means I'm focusing on this angle A. Now, I don't know what the angle is. I don't know if it's 30 degrees or 80 degrees or what it is. I really don't care what it is. If I'm just being asked to write the ratio of the sides for the sine of the angle or the cosine or the tangent, I'm going to use SOHCAHTOA. So I know that the sine is the side opposite angle A, which is little a, over the hypotenuse, which is little c. And you just write it like that. It's going to be a number, like maybe a half, or maybe root 2 over 2, or, you know, it could be anything, any kind of fraction. And the cosine of this angle, we know that the cosine is the side adjacent or next to that angle, which is little b, over the hypotenuse, which is c again. So there's the cosine of that angle. And then we know the tangent is the side opposite angle A, which is little a, over the side adjacent angle A, which is little b. Okay. Now likewise, we could find the sine, cosine, and tangent for the other angle, for B, this one over here. And I'm just arcing it different because this is just a generic right triangle. I don't know if it's a special right triangle. I don't know if it's not a special right triangle. You know, this could be, I don't know, 40 degrees, and this could be what remains. But anyway, I'm not sure what the measures are, so I'm just noting that it's different by marking it with 2 arcs. So the sine of this angle B is the side opposite over the hypotenuse, so B over C. The cosine would be the adjacent side over the hypotenuse, so little a over C. And the tangent would be the side opposite that angle, so little b is opposite angle B, so little b over the adjacent, little a. Okay? And again, notice that the tangent of the angle A is just the reciprocal of the tangent of angle B. Notice this is A over B, and this becomes B over A. So, you know, from those acute angles there, whatever they are, the tangent just takes on the reciprocal. Okay? Hopefully you remember that. If we do one with some side measures now, you know, again, I have no clue what these angles are. I know the angle C is 90, but, you know, I don't know what A or B are, and I can't make up stuff, right? I can't assume anything. But I may be asked on my semester exam, on my in-class test, in my homework, to write the ratios of the sides for the sine, the cosine, and the tangent. So again, for angle A, I used purple and arced it off here. You always want to arc the angle that you're working with, so that way you can focus on the angle and not mistakenly use the other angle, the side opposite or adjacent of the other angle. So if I'm focused here on angle A, I know that the sine is the side opposite over the hypotenuse, so 12/13. The cosine of this angle is the side adjacent over hypotenuse, so that's 5/13, and the tangent of this angle would be the side opposite over the adjacent, so 12/5. And likewise, if I decided to focus on angle B and find the sine, cosine, and tangent, well, the sine is side opposite over hypotenuse, so we get 5/13. The cosine is adjacent over hypotenuse, so we get 12/13. And the tangent is opposite over adjacent, so we get 5/12. And again, numerically, you can see that this tangent of A is the reciprocal of what the tangent of B would be. Okay? Now, we studied special right triangles. In particular, I'm going to focus on the 30, 60, 90. Why? Because you know that we have a short leg. The long leg is the square root of 3 times the short leg, and the hypotenuse of a 30, 60, 90 is 2 times the shorter leg. So I just let the short leg be x here, right? So that means that the hypotenuse would be 2 times that short leg, so 2 times x is the hypotenuse, and the longer leg, the side opposite the larger acute angle, will be the square root of 3 times the short leg. Okay, so in this case here, if I want to state what the sine of 30 degrees is, well, I mark off that angle, so let's see, I did it in purple. The sine of 30 is the side opposite, which is x, over the hypotenuse, which is 2x. Now these you need to clean up, right? So I didn't cancel these when I wrote this up, but I'm going to do it now. I guess I'll use pink. But, you know, I can cancel an x for an x top to bottom. So, you know, x goes into itself one time up here, and it goes into itself one time. 2 times 1 is 2 on the bottom, and 1 times itself is just 1. So anyway, you end up with a half. So the sine of 30 degrees is 1/2. The cosine we know is the side adjacent or next to this angle, so it's x root 3 over the hypotenuse. And again, I can cancel an x for an x. Oops. Not going to work. So I'm going to get square root of 3 over 2. Okay, there's no radicals in the denominator, so I don't have to rationalize. For the tangent, though, of this angle, it's the side opposite over the adjacent, so it's x over x root 3. Now here, I can cancel an x for an x, so I get 1 over root 3, and as you recall, we cannot have a radical in the denominator, so we rationalize by multiplying up and down by the same indexed radical, so the square root of, in this case, 3. And so on top we get 1 times root 3 is root 3, and root 3 times root 3 is just the square root of 9 or 3. So remember, if you multiply two radicals with the same number inside, then the number inside comes out of the radical. Okay. Now I could also have focused, and I did, on the 60-degree angle, the sine of 60. So now I'm focusing on this angle here, is the side opposite, so x root 3 over the hypotenuse. So here the x's are going to cancel, so I get root 3 over 2, and that's just some decimal, and you leave it like that. You're done. The cosine of 60 degrees is the side adjacent over the hypotenuse, so that's x over 2x. Again, I can cancel an x for an x, so we're left with 1/2. And then the tangent is the side opposite over the adjacent, so it's x root 3 over x. Again, the x's cancel. I don't have a radical downstairs, so I'm done. Okay? Just writing the ratios. So again, whether, like up here, whether I don't know what the angle is, maybe I might need to try and find it, and we're going to talk about that in a second. Or maybe I do know what the angle is. Either way, it doesn't matter. It's the same process, either way, okay? If you're asked for the ratios of the sides, everything's the same. Now, when we need to find the angle, that means you got to use your calculator, right? And we did this in class. Now, I don't have an FSA calculator handy with me. I guess I should keep one in my purse. Because remember, you guys are going to have to go backwards. But for those of you with the scientific, let's get the calculator set up first. Let me make that a little bit bigger. Remember, your trig keys are here, sine, cosine, and tangent. And just above that, you'll see the sine to the -1. It means sine inverse or inverse sine. Cosine to the -1, tangent -1. Those are the things we need, that little sine, cosine, or tangent to the -1 power, in order to find the angle measure. So in order to employ those, you're going to have to press the blue second key, which will perform the blue function above. Okay. First thing you need to do, though, is press your mode key and make sure. Now I'm in degrees because I haven't used my calculator since before the break. But you notice if radian is highlighted, if you look at your calculator, oops, and it looks like this, then you're going to have a problem because we're not working in radians, we're working in degrees. So if that's the case, all you have to do is press the mode key, scroll over to degree, and press enter. And that'll take you off radian mode and put you in degree mode. So when you're working with trig, you need to make sure you're in degree mode. Otherwise, you're going to say, Ms. Wilson, I'm getting some weird little numbers. Okay, you're going to get these weird little decimals rather than, you know, degrees. Okay, so now we go back to the home screen. So the thing is, we're going to use the same process, but we're going to use the inverse key on the calculator, and you're only going to use what is given. So the question is this, you're given this on the test, and you're asked maybe to find the measure of angle A. Okay, so I need to find the measure of angle A here. Well, am I going to use the sine, the cosine, or the tangent? I don't know. What do I have? I have the side opposite angle A. Well, that's a sine, right? And I also have the hypotenuse of that triangle. Hey, that's the sine function. Can I use the cosine? No. Now, I know you can say, well, hey, I could use Pythagorean theorem and find that missing side. You can, but number one, it's a lot of work. And number two, it's probably going to come out just a little bit different than the answer choice on your multiple choice test. So don't do it. Especially on the FSA or on your semester exam, when they give you something like this, decide which you have. Do you have so, ka, or toa going on here? And use what they give you, so that way it comes out precise. So I know that the sine of, I know that in order to find this angle A, I have the side opposite and the hypotenuse, so I'm going to say the sine of A is equal to the opposite over the hypotenuse, right? But in order to find angle A, that implies, that's what this double-headed arrow, or this double arrow means, that implies that the angle A is equal to the inverse sine of 18 over 21. So you don't have to write all this down. What you do have to do is press second sine, because we're using the sine function, in your calculator and put that ratio in. So I'm going to do that one. I'm just going to move it over a little bit so I don't forget what the numbers are. Okay, so I'm going to press second sine, and you're going to see that little sine to the -1 power, which again is pronounced inverse sine or arc sine. And it says 18 divided by 21. So I'm just pressing 18, the division key, and the 21, close the parentheses, hit enter. So I know that the measure of angle A, I'm going to round to the nearest angle, is 59 degrees. So what I know is that angle A, the measure of angle A, is approximately 59 degrees. Okay, let's do another one like that. So let me just make up a triangle here. Let's call this A and B and C, and let's call this, I don't know, 15 and 3. And I ask you to find the measure of angle B. I want to know what is the measure of that angle. Oops, sorry. So you say, okay, do I use a sine, a cosine, or a tangent? Well, look, I don't have any information about the hypotenuse, so that automatically eliminates sine and cosine. If I don't have anything there on my hypotenuse, I can't use sine or cosine. The only thing I can use is the tangent. And I know that the tangent of the angle B, that's the angle we want the measure for, is equal to the side opposite over the adjacent. Now you could reduce that to a 5 if you want to, but rather than that, we're going to do second tangent, and we're going to do 15 divided by 3. And so the measure of that angle is about 79 degrees. So we would say B is approximately 79 degrees. Okay? Capiche? So I know that you did some of the evens in your notebook before the break, and sorry, I made a mistake there. I've got a lot of videos to do tonight, and I'm tired, and I'm just trying to get them all done and uploaded. So what you're going to do is you're going to work on the evens tomorrow in class. I'll put it in the lesson plans for the substitute. And behind my desk in that book cart is the teacher edition of the book. So even though they're the evens, you know, you can ask the substitute to pull the book out and leave it like on the Elmo table. You can open to that page 567, and the answers are there in red, and that way you can kind of check and make sure you're on the right track with your answers. Okay, So don't forget to do those. They need to be in your notebook, vertical, line in between, perfection, right? So that way I don't take off lots of points for the next notebook check. And I hope this helps, and we'll see you next block. Have a good night.